This video focuses on significant figures in measurements. So students, stick around, watch and learn. What are significant figures? A significant figure contains one or more certain digits plus one doubtful or uncertain digit. If the first certain digit is 0, it is not significant. As an example, 0.4 grams. This measurement, the 0 is certain but not significant, and zero point 0.4 is doubtful but significant. Therefore, this measured quantity, 0.4 grams, or commonly written as zero point 0.4 grams, only has one significant figure. The number of significant figures of a measured quantity determines the precision of an instrument. Suppose you did a simple measurement activity. You measured the length of a table using ruler X that has its smallest calibration in centimeter and ruler Y with its smallest calibration in the millimeter. If the actual length of the table is 51 centimeters, which entry in the chart below is considered the most acceptable measured length and why? So this is the diagram for ruler X. As shown, the smallest calibration is said to be 0.1 centimeter or 1 millimeter, whereas ruler Y, its smallest calibration is 1 centimeter or equivalent to 10 millimeters. And the length of the table measured, okay, supposing this is the table, okay, it's understood that the measurement of the length of this table started from 0. Okay, the left edge of the length of the table is exactly aligned at the 0 centimeter mark. And this is the other end of the length of the table, which or whose exact length is given as 51 centimeters. So we are asked to determine which among the four choices A, B, C, and D gives the most acceptable measured length of the table using ruler X and ruler Y. Examining the given measurements in our options A, B, C, and D, it's obvious that in terms of the magnitude of the length or the value of the length of the table, all entries in A, B, C, and D are equal. if you're just talking about the values of the length in centimeters. But in terms of precision, okay, in terms of the precision of these measurements, these entries are not the same. All right? So we have to analyze each of the given ruler X, for example, right? Which we say has the smallest calibration in zero point 0.1 centimeter, or that's exactly 1 millimeter. All right, that's the smallest calibration that we can see here. Okay, so therefore, if you're going to use the definition of significant figures, okay, it looks like that the digits 5, 1, and the first 0 after the decimal point are all certain, all right? While the second 0 is considered uncertain or doubtful. The first 0 is certain because ruler X is calibrated up to the nearest tenth of a centimeter. Since any given measurement must contain, okay, by definition of significant figures, okay, any given measurement must contain one or more certain digits plus one and only one doubtful or uncertain digit. It follows, therefore, that the best length measurement for ruler X must be 51.00 centimeters. For ruler Y, only the digits 5 and 1 are considered certain, and the digit 0 is uncertain or doubtful. This is because ruler Y, or the calibration, smallest calibration of ruler Y, is up to the nearest ones, or the nearest whole number of a centimeter. Since, as mentioned earlier, any given measurement must contain one or more certain digits plus one and only one doubtful digit, the best length measurement for ruler Y, therefore, is 51.0 centimeters. And so therefore, if we are going to combine our analysis for ruler X and ruler Y, okay, our best answer to this question is that letter A, where the measurement for ruler X is equal to 51.00 centimeters, while the measurement of ruler Y must be 51.0 centimeters. There are certain rules in determining the number of significant figures from a given measured quantity. Rule number 1 says that all non-zero digits are considered significant. Example, 1.3 kilometers. This measurement has two significant figures. Both 1 and 0.3 are significant. Rule number 2, zeros in the middle of non-zero digits are significant. Example, 1004 grams. All the digits 1, 0, 0, and 4 are considered significant, so there are 4 significant figures. In number 3, zeros to the right of a decimal point are significant. Example, 295.00 centimeters. All the digits 295 and the two zeros after the decimal point are considered significant. So there are 5 significant figures in this measurement. Rule number 4, zeros immediately after a decimal point are not significant. Example, 0.023 newtons. Alright? The zero that is immediately after a decimal point referring to point 0 is not significant. So, there are only 2 significant figures in this measurement. The digits that are significant are 2 and 3. Both the zeros are not significant. And the last one, zeros as ending digits of a whole number are not significant. Example, 1,200 joules. In this measurement, only 1 and 2 are considered significant, while the two zeros are not considered significant. There are also rules on significant figures when we are doing the 4 um, basic operations: addition, subtraction, multiplication, and division. So let's talk about multiplying and dividing numbers. Okay, the rule is no more than in the number of fewest significant figures. Okay, example 1. 0.683 multiplied by 5.2 and then divided by 4.786. We do away with the usual units for simplicity. But these numbers or measurements are real measurements. Alright? So, with the help of your calculator, this is what will come out. 0.74208.107. Then you have to decide, okay, for the final answer, okay, how should you round it off so that it will only have 2 significant figures? Because our basis here is the quantity with the least number of significant figures, and that is 5.2. It has 2 significant figures. So therefore, our answer must also contain 2 significant figures. And rounding this number, 0.74208.107 to 2 significant figures will make it 0.74. Alright. Our example 2, when we are multiplying numbers expressed in powers of 10, like 2.8657 raised to the 5th power multiplied by 7.16 raised to the negative 2. Alright? So with the help of your calculator also, this is what we will get. 20.518412 raised to the 3rd power. So, between the two numbers, 7.16 raised to the negative 2, okay, has the less number of significant figure, which is 3. Therefore, our answer has to be rounded, okay, to 3 significant figures. And this, alright, 20.518412 should be rounded only to 20.5 times 10 to the 3rd power as our final answer. This contains 3 significant figures. Now, for addition and subtraction, the rule is determined by the number of smallest uncertainty. That is, the fewest digits to the right of the decimal point. If you're talking about numbers with what do you call, decimal, with digits after the decimal points, or for numbers that are expressed in whole numbers. All right, let's have example number 3. So these 3 numbers contain numbers or digits after the decimal point. Like 27.153 has 3 decimal places, 138.2 has 1 decimal place, and 11.74 has 2 decimal place. So when added and subtracted, this is what we will get, 153.613. And of course, we have to decide how many decimal place or places should our answer have. Okay, if you're going to follow the rule, 138.2, among the 3 given quantities, 138.2 contains the least number of decimal place. It only has 1 decimal place, and therefore our answer has to be rounded, just like 138.2, which has only 1 decimal place. So when rounded to 1 decimal place, this becomes 153.6, right? Notice that our rule for addition or subtraction is not exactly the same as the rule for multiplication or division. If in multiplying or dividing, all right, we consider as the basis the quantity with the least number of significant figures as our basis. For addition or subtraction, especially when dealing with decimals, all right, what we use as basis is the one with the least number of decimal places, right? Not the number of significant figures, but it should be the number of decimal places. Whichever has the least number, that becomes our basis, all right? Now, in example 4, 500 is a whole number. It has no decimal. It has no digits after the understood decimal point here. But the other one has 1 decimal place. So, with the help of your calculator, you will actually get 431.5. Alright? Should this be the final answer when you're doing this subtraction? Or should it be rounded? Alright, it should be rounded because this time we have to follow the certainty of 500. Okay? We say that 500 as a measured quantity only has 1 significant digit, and that digit is 5. The 2 zeros are not significant. Alright? So our answer therefore has to be rounded in such a way that it only contains 1 significant figure or digit. But a number that is closest to 431.5, and that number is, of course, 400. All right? And in that measured quantity, 400, whatever, for example, that is 400 joules, okay? This measured quantity, 400 joules, or computed quantity, only contains 1 significant figure. We now have our first question, which is a multiple choice question. If the smallest calibration of a metric ruler is 1 millimeter, which of the following is correctly written as a measured length? Option A, 200.400 millimeter. Option B, 200.40 millimeter. Option C, 200.4 millimeters. Or option D, 200 point millimeter. All right. So, may I just clarify that choice letter D, 200 with a decimal point, all right? This means that this measurement has 3 significant figures, meaning the 3 digits 2, 0, and 0 are all significant. So that's one way of emphasizing if a whole number such as this, ending in zeros, okay, if the two zeros are meant to be significant, then you have to put a decimal point after. All right. So what will be the final answer or the correct answer in this question? All right. The rule is if the smallest calibration is given, in this case 1 mm or 1 millimeter, it means that we can have a measurement. Okay, we can have a measurement that will contain one decimal place of a millimeter. In other words, the precision is up to 1 or point 0.1 of a millimeter. Right? And among the four choices, it looks like letter C. Okay? Letter C is expressed up to the nearest tenth of a millimeter. So it is the best answer among the four options. For our question number 2, which is the correct computed value for the sum of the following measured quantities? The two measured quantities are masses. M1 is 35.00 grams and 20 with a point, okay, gram. So again, 20 with a point after the 0 means the 2 and the 0 are considered significant. So when adding these two numbers, all right, we just have to stick to our rule for adding numbers or measured numbers with the least number of decimal place. Okay, the sum of these two, of course, is 55 grams. But among the four choices, 55 grams, letter B 55.0 gram, letter C 55.00 gram, and letter D 60 gram, all right, the best answer must be letter A. All right, it is letter A because between the two given, we have to follow the precision of the second quantity, which is 20 point gram. Our answer should contain also two significant figures. And among the four choices, it is only 55 grams, letter A, or 55 grams, which contains two significant figures. All the others, like in letter B, this has 3. In letter C, this has 4 significant figures. And in letter D, it only has 1 significant figure. Question number 3. The figure shows a thermometer calibrated in Celsius degree. The best reading in degrees Celsius is letter A 10.4 degrees, letter B 10.42 degrees, letter C 10.47 degrees, and letter D 10.5 degrees. The correct answer is letter B 10.42 degrees. Here is the explanation. The smallest calibration of this thermometer is 0.1 Celsius degree. Its precision, therefore, is 0.01 Celsius degree. And as shown in this drawing, all right, the level of alcohol in the thermometer is above 10.40 degrees Celsius, but less than 10.45 degrees Celsius. Hence, 10.42 degrees Celsius is a more logical estimate than 10.47 degrees Celsius. So the answer in letter B, which is 10.42 degrees Celsius, we say has four significant figures or digits. Digit number 1 is certain, 0 is certain, okay? 4 is also certain since it is backed up by our drawing, which indicates that the smallest calibration is a tenth of a Celsius degree. The last digit, which is 2, is just an estimate or estimated digit, so it is uncertain or doubtful. And by definition, we say that a significant figure has one or more certain digits plus one and only one doubtful digits. Question number 4. Round up the measurement 9,682.543 meters to three significant figures. The options are letter A, 9,700 meters, letter B, 968 meters, letter C, 9,680 meters, and letter D, 9,683 meters. The correct answer is letter C, 9,680 meters. Here are the explanations why the other options are considered incorrect. In letter A, 9,700 meters has two significant digits. Both 9 and 7 are considered significant and the two zeros are not significant. For option B, 968 meters has three significant figures, but its value is two way off the original, which is 9,682.543 meters. When we say round off, it simply means that the acceptable answer must be a measurement that's not too far from the original measurement. Okay? But 968 meters is just too far from the original measurement. Letter D, 9,683 meters, is not the correct answer either because although the value of 9,683 meters is quite close to 9,682.543 meters than our answer, which is 9,680 meters. But 9,683 meters has four significant figures. Okay, 9, 6, 8, and 3 are all significant. And the answer that we want should have only three significant figures. So that makes letter C as the best answer. We are now down to our last question. Question number 5. A 9.40 gram sample of powdered titanium was added to a graduated cylinder originally containing 6.8 ml of water. After addition of the titanium, the water level in the graduated cylinder was 8.9 ml. Calculate the density of titanium and express the answer to the correct number of significant figures. So our solution, we first get the actual volume of the titanium powder. We simply subtract 8.9 ml minus 6.8 ml to get the volume of titanium, which is 2.1 ml. Alright? So this measurement, 2.1 ml, has two significant figures. We then proceed in calculating for the density. Density is equal to mass per unit volume. And when we substitute the value for the mass, which is 9.40 grams, to be divided by the computed value of the volume of the titanium powder, which is 2.1 ml, we will get the computed value for the density of titanium powder, which is density equals 4.5 grams per ml. So our answer has been rounded, okay, to two significant figures because when you do the division, okay, our basis should be the quantity that's the less number of significant figures, and that is 2.1 ml. So our answer should also have two significant figures. Thank you very much for watching. Please follow me in my FB page, and please don't forget to subscribe to my YouTube channel.